Yeah, okay, thank you. And please don't be afraid about this 100 plus slides. They are just for reference, and maybe we can sort of give you, once I give you the PDF, you can process it. That's the whole idea. So I'm going to skip some of these slides, and also hopefully it will make sense to us overall. What I intend to say, and let me also know whether my slides are moving or not as I go. Are they moving?
Yes.
Okay.
Yes.
Yeah, thank you. Okay. So AI is the future of this. That was, I think, the a very interesting point that Dennis asked me a couple of weeks back, and I sort of got fascinated, specifically because in 2012 I had proposed one particular new law of TRIZ, I wanted to call that, and in fact I wrote a paper which was published at AI TRIZ Institute in US. Richard Langevin actually published and put it on the site. It's called The Law of Increasing Intelligence of Technical Systems. And there I'm going to show you that particular part also, and also sort of give you where last 10, 15 years that I have been processing that, and also trying to integrate trees, or also looking at how trees should be evolved, is what we should be aiming at from specifically from intelligence perspective. Before we get to that, let me maybe ask some few questions. So this was a very old quote that I had in my school days, in my college days actually, in late 1980s. This was the question was, can machines think? And the answer was attributed to a comedian in Hollywood named Bob Hope, and he said, no, they only think they can. Now, my question today is, can humans think? And where is the evidence of our thinking? This, I think, is the fundamental question about when do we say we are thinking? And secondly, of course, can machines think for you? Can machines think with you? Can you think for machines? Can you think with machines? So these are, I think, the questions that we should be aiming at trying to answer ahead. And here is where TRIZ purpose needs to be looked at from the point of view of what Altshuler was trying to do. And as we know, he was basically trying to say that method of inventing, which has stood sort of test of time, and also our human nature is like what we typically try to solve problems by trial and error, right? So that he wanted to avoid that, wanted to create a system or a systematic procedure or a algorithm, if you may, of how to invent, how to solve inventive problems as he classified them. And the question now I think we need to really look at is, are we outsourcing this trial and error to machines with our current AI machine learning deal, or are we trying to really think about how we really systematize and integrate this intelligence capability that we are getting from machines into our integrated systematic approach to solve problems? So this, I think, is a little bit a digression from the flow of thought and flow of inputs that I'm seeing so far. So maybe it may look little out of sort of context. But having said that, I think the question is about what exactly are these so-called thoughts and ideas. And here a little bit of work that we have done and trying to go to the so-called first principles thinking, as it has become popular now, to look at exactly when we say about thoughts and ideas, what do we mean by that? And this is where we basically are talking about some sort of changes that we are looking at in the physical world, in the informational world, and the living world, and also some sort of a cognitive aspects. So interestingly, when we really study this, or when we try to analyze this, we actually look at this so-called set of substrates. There seems to be the four key substrate that we have, which is the physical world, which is energy and matter. then the informational world, then the living world, which is the living world that we have, the life that we have on planet Earth, and then of course the cognitive world. How do we interpret in the cognitive space that we have? So when you combine these four so-called substrates, we basically look at these what we call the cognitive domain or substrate, living domain, informational domain, and physical domain. And we call these as a clip substrates or four substrates that we are looking at. So when we're talking about change or ideas, we are basically trying to look at how we change this configuration of these so-called four domains or substrates in space-time and or in the other dimension that we are looking at. So this type of a map of our thoughts is what we are trying to change when we are looking at so-called ideas. Ideas are nothing but changes in how we actually create some sort of a possible purpose or value or objective, so to say, right? So this way, if you really look at uh, we are trying to comprehend and also uh, convert these thoughts into these changes which gets manifested in some sort of a value, so to say. But if you really look at the amount of change that we have seen in last 15 20 years, or in fact much more than that, we are actually seeing much more rapid changes across the world. And this is where I think it becomes very very important to understand how complex is this change. And when we talk about ideas, are these ideas really well formed ideas, or are they really just the tip of the iceberg or some sort of a wishes that we have? And typically, this is where we have found TRIZ helps us to actually not only understand how to generate ideas, how to formulate problems, but also evaluate the strength of those ideas, because it has given us very nice way to qualify each and every invention. In fact, the strength of invention or the level of inventions or inventiveness of a idea is actually one of the very very important tools. Somehow we are missing that particular tool because somehow this seems to be confined to these 39 parameters, 40 principles, and some sort of effects that we actually can get from. Somehow the TRIZ community or the TRIZ practitioners have reduced TRIZ to a problem of search, which is actually much more than problem of thinking or creating a structure for thinking. So here my agenda is to look at couple of points and which I'm going to focus on these creative destruction and how do we really look at these technological changes that we are seeing. Here I'm going to propose, and in fact we have couple of write-ups and couple of books written on this particular new metric of how do we evaluate these numbers that people keep on throwing in terms of how many number of patents per year are being sort of filed in each particular keyword or in each particular type of domain. But actually, does it make sense to really look at what those numbers actually say? Here we have a new metric that we have proposed last 6 7 months back, and a couple of books on that, which I'm going to just refer to you and also show you what this means. And also look at a couple of tools that we have developed on evolving TRIZ towards looking at this new age of technology. So that is the sort of agenda, and I'm hoping that I'm going to be able to finish this in the time that I have. As we said, that complexity has increased not only in terms of the inherent number of dimensions in which we are seeing changes, but also their interactions and also the availability of these changes for the whole world. If in fact everyone has this particular capability to change. And one of the person who studied this particular type of period in any history in our history is this person named uh, uh, Schopenhauer. Oh, sorry. Uh, I think. Okay, I'll just come back to the name. This particular person actually proposed a concept called creative destruction. This, he said, this the creative destruction happens over a particular time period in the whole world that we are seeing in the economy. And he basically said that newer technologies from the system, from the inherent from the system, actually create newer type of value, and they replace the existing economic value creation technologies in a fundamental way. And this he called creative destruction. My point is that we are actually seeing a new creative destruction here, and also giving way to new type of the wave of innovation, and which we call the sixth wave of innovation. I will explain that, but before that, I would like to explain this metric that we have, which we call the inventive energy metric. And this is the book that we have, which has a combination of two metrics, which we call the patent activity index and patent intensity index. And these two index, when we combine into what is happening when we are seeing the patent filing trends, we can actually look at not from the keywords perspective, but from what is called the international patent classification, or the IPC classes, which every patent gets a IPC class, or at least a set of classes. And using these IPC classes as the domain, we can actually see these patterns that we, and also evaluate where is this energy of human intellect or human inventive energy is being either utilized or applied. There we actually found that what we have seen in last 10-15 years, we are seeing these three trends that are clearly visible, which we call the sixth wave of innovation technologies, where the aim is that we are making things nano, networked, autonomous, and hypersonic, using algorithmic intelligence with quantum computing coming maybe in 5 to 10 years now ahead, and then which will give us a capability to synthesize biology, energy, and reality, and which includes this hybrid reality, virtual reality, and all those sort of things. So this type of analysis gave us these new drivers for sixth wave of innovation. And in fact, we can actually see whenever these new wave of innovation emerges from the creative destruction, as we have seen in the history from last so many years, these waves actually create a new world, so to say. And when not only these waves create new world, it also creates new type of conflicts in the system or in the world, which leads to wars and also different types of reorganization of wealth, so to say, which we are actually seeing in these. So interestingly, this study was done, and this the fifth wave of innovation was driven by what they call the digital network, software, new media, from 1990 to 2020. And in fact, if you now see 2020, we saw the epidemic, the pandemic, and also actually sort of looked at what will be the next wave of innovation. And this is where this study actually becomes more interesting and useful, to see where these technologies, where these patent trends are telling us the world is going, and which of these technologies are going to really create the so-called positive or the creative side of the creative destruction of the sixth wave of innovation, as we said. Now, in this book that we have, which we call the Inventive Energy of the Sixth Wave, we actually looked at these technologies from the patent trends once again, but this time looking at the sixth wave of innovation technologies that we called, and this is what has been published and available. And in fact, this actually gives us very clear clear indication of where these intensities of patent effort is going ahead. So just to give you this flavor, now this is the first part of my presentation in terms of when we are trying to look at the overall patent trends, we should not look at only the patent numbers, but also the this inventive energy metric, which combines the patent applications and patent granted patents, and there is a gap in between them, and also the IPC classes, which actually gives us a much more rich, much more robust way to evaluate. Now, looking at these particular trends that we have, the world that we have today is, as we said, the competitive advantage is coming from innovation, as we have been saying. But as we go ahead in the so called sixth wave, as we call, the newer capability of competitive advantage at your individual level or company level or country level also will come from how fast you co-create with increasingly intelligent machines. And somewhere in future you have to create systems which will be fast design of wishes for the for anyone who really wants to do. And this, I think, is the challenge that we are exploring here. Now, here is some work that we have done. As we said, the TRIZ levels of inventions, the 5 levels of invention that we have, actually are very, very useful inputs. What we have done, we have quantified them through certain methods, and in fact, we have a small tool. And as some of you will know, these levels of invention at level 1 and level 2, which is about 77% patents, as Altshuler and his disciples found, were only small improvement. And here the contradiction metric stops actually at level 2. At level 3, we get to something called a physical point contradiction, which is about 19% patents. And also at level 4, we have a totally new type of system, which is just 4%, and level 5 are almost closer to discoveries or application of scientific. Now, how what we have done, we have a small method of looking at when you are evaluating a particular idea or particular solution that you are proposing compared to what is existing, what exactly is the quantum of change and the quality of change that you are actually proposing compared to existing art. Now, this gives us a very nice way to evaluate, and which we call how the system architecture or system anatomy or system hierarchy is being changed. And as you see, can see changes in supersystem, changes in system, changes in subsystem, we have actually qualified certain specific questions. And looking at your particular idea or particular invention or inventive solution, we can look at what exactly you're changing. And this is where it becomes very interesting. But let us look at this Apple's patent from 2005, which was actually on this swipe login to the touch screen. And in fact, when we apply our perspective, we can see that uh, this is a pretty straightforward application of contradiction matrix. But when we try to evaluate where it lies and quantify it, and this is where our tool comes into picture, which actually gives you a very nice way to asking you specifically what are the changes that you are looking at, and also what are the changes that compared to existing system, what it is proposing. And you can actually sort of give these scores, and those scores gives us a overall quantification of where this particular level lies. Secondly, we also have done some work on how much is the height of inventive step that we actually are seeing. And here we have, instead of using the quantitative in the contradiction matrix or the parameters, we actually looked at the laws of evolution or the lines of evolution or the trends of evolution that are there in trees, as you may know. And this, I think, has given us a very nice way to quantify and also construct a mechanism for thinking ahead of any system, these lines of evolution. And in fact, it can give you, compared to the prior art, where is your invention. As you can see, the red parts are what you actually are doing with your invention, and this can give you a clear picture of what we are looking at in terms of where is this quantity or the invention is in compared to the prior art. Now the question is,
Navneet, five
yeah,
minutes more. 5 minutes
okay.
more.
Okay, so what I will do, I'll just quickly give you my main points. This is what our classical trace is, right? This is our, which has the laws of evolution, technical system evolution, and also tools for development of conceptual design. But what we have missed out in trace in the information era are those software patterns which were not there or were not analyzed, so to say. Okay, so what we are looking at here, the information era trace and the mind era trace, which we are calling now the intelligence era trace, is looking at a totally new way to approach inventiveness or the inventive solutions. Now, here is what we are trying to explain. System with a some sort of a mind of its own is what we are inventing when we are talking about the intelligent era. And this is where our point about the new law that we proposed in 2012 comes into picture, because we said the dumb systems and guided systems became smart. But then we in 2012 we started looking at what we call the brilliant systems, and then somewhere ahead we are going to move towards what we are calling the genius systems. Now, in this typology, in this particular method of qualifying systems into more and more increasing intelligence, we actually can get to where these genius systems are or where they will be here. And how, what are those parameters beside the 39 classical parameters which should be looking, we should be looking at as the capability of the system to have so-called brilliance or so-called genius capabilities of any system, if you really looking at. And here we actually looked at the when we have a structure or a system, and of course the system performs a particular function, there is an interface in between as per TRIZ, which is called the operating principle. So this particular tool that we have, system function interaction tool, actually combines the interface, which is the operating principle, and also you can see the 39 parameters are here, but for the guided, for the smart, brilliant, and genius systems, we are looking at newer parameters, and also for each operating principle, what sort of system we should be exploring. Now, if you really look at the example here, the toothbrush, for example, from the fourth wave of innovation, which is classical TRIZ, this will be our function map tool acting on an object with performing a cleaning function. But if you look at newer way, a tool will also have a memory, also have sensor, also have computation, and it will have choices to see which particular operating principle to implement, whether to use ultrasound waves, whether to use a particular type of friction or a particular type of ionic action. And runtime, it will decide which particular teeth of in your mouth requires which particular type of operating principle to be used to clean it. And this, I think, is a newer type of capability that is going to come, or which we call the genius systems or the brilliant plus genius systems, which is the evolution. Now, the second part
Conclusions?
is, yeah.
Conclusions?
Okay, just one point. The 7 lines of intelligence that we have also mapped includes all these stages of this particular movement towards intelligence. So let me go to conclusions, as Dennis is saying. Also towards hopefully this will be the final couple of points about where the system intelligence actually work. So I'm just running through these slides to give you the flavor, but of course you can go through them. My point here is that we need to really evolve this towards much better capabilities, specifically catering for newer type of world that we have. So system capability enabling parameters we need to identify from the 39 parameters that we have. Also look at the newer ways in which our systems, which are becoming more intelligent, and also we working with them more intelligent system, how do we team with them? So this is the second part. Then discovering new laws of evolution. I think this somehow we are missing out, which we can utilize the AI for finding out new laws of evolution, just like what we talked about, the law of increasing intelligence. Third is, instead of inventive problem solving, we need to really evolve to innovation problem solving, which is a much broader problem. And here, I think the whole system of innovation needs to be evaluated, and also TRIZ has to be expanded to look at what are the new thinking dimensions that we should have. So here, we propose these 5 dimensions of thinking that we already have, plus the newer thinking, scale thinking, computational, algorithmic, and network thinking, and also upcoming nano and quantum thinking has to be sort of looked at how we integrate with our existing thinking capabilities. So this is, I think, the main
Thank
4 points.
you.
And the fifth point, let me finish with the fifth point. We need to integrate TRIZ as a thinking dimension rather than as a search problem solving perspective that it has been reduced to, which is, I think, the main point from TRIZ was. Now, how will we evolve TRIZ? Here, I think the key question is we need to explore what we call the uncommon part of the common sense and the common nonsense, as we call look at. So, how do we really explore the uncommon sense and uncommon nonsense? Is, I think, the key criteria for evolution. And here we need to become innovation co-crafter. Finally, I'll just look at Taleb's point about those who talk should do, and only those who do should talk, from skin in the game. So whoever has skin in the game, meaning who are doing, is not by applying newer solutions or newer tools, but actually creating newer ways of thinking, should be the people who should be working together or actually exploring. So my point here is the laws of evolution or the work that is had was from till the fourth wave of innovation. Fifth and sixth wave of innovation, the corpus has been missed out in evolving trees. So why not we use that corpus of inventions that we have for last 30, 40 years and also create a newer version of trees as per. Okay, so our essential
Thank
task,
you.
as per Herbert Simon, is to actually keep open uh, the variety and also create newer variety. So finally, Richard Feynman's point: if our small minds, for some convenience, divide this universe into parts, nature does not know it. Okay, I'm sorry for the time that I have taken. I hope we can always touch base on email or my number, and also if you have questions, we can also have these them now, or if Dennis allows later on. Thank you for your patience.
Thank you. Thank you for your very dense and overflowed of slide. One question, but I believe you would agree to share your slide with the audience in order that we take time to carefully review and read them carefully one by one, since we haven't had time to listen to you for 2 hours, which is the mean time for 114 slides. So you have made the um, the very good result of presenting 114 slides in 25, 30 minutes. Thank you very much.
Yeah, I'm going to
Uh,
share the slides. I'll send it to you, and you can share with the audience. Thank you.
Thank you. We always glad to hear about the activities abroad, and we have had a sample with your very dense series of slides. Thank you very much
Thank you, Dennis.
for your presentation.